In the last video, we looked at properties of exponential functions. Now we're going to see them in action as we look at graphs of exponential functions. All right, so here we go. We're going to just sketch the graph of 2 to the x. All right, and then also 1/2 to the x. Okay, so if you need help graphing these, I recommend, and actually I probably would make a table of values myself. So I'm going to do f of x in blue, and then I'll do g of x in green. Okay, so I'm just going to do -2, -1, 0, 1, and 2. And then if you feel like going further, you can. I think 3 will be just fine here. So we get 1/4, 1/2, 1, 2, 4, 8. And if you need to check those with a calculator, feel free. You would just insert the values for x into the exponent and simplify. Okay, so as I plot these, I get something like this: 2, 1, 2, and then 2, 4, and 3, 8. Okay, and then -1, 1/2, -2, 1/4. So I get something that looks very much like this. Oh, I missed my point. Okay, yeah, get the idea. All right, and then I'm going to do g of x in green, so x and y. Okay, so -2. Now this one I can actually do -3, -2, -1, 0, 1, and 2. So I get 0, 1, 1, 1/2, 2, 1/4, and then 2, 4, 8. Okay, so 0, 1, 1, 1/2, 2, 1/4, -1, 2, -2, 4, -3, 8. Okay, so I get something that looks like this. Okay, and so what do you notice? Well, they're kind of mirror images of one another. Okay, and that actually makes sense because if I look at this one, I could write this as 2 to the minus x. That's a horizontal reflection. Oh, yep, all that's coming back. All of our vertical reflections, horizontal reflections, all that's going to come back to us. Okay, so we will see transformations in just a bit. But other than that, what did we talk about in the last video? We talked about the y-intercept being at 0, 1 for the base functions. Yep, we see that. We see for the blue function that is increasing, right, when b is positive, right? So here we have b is greater than 1, and here we have b being between 0 and 1, okay? And in that case, we said it was going to be decreasing and concave down. And similarly, for the b is greater than 1, we said it'd be increasing concave up. And lastly, we do see a horizontal asymptote, right? The x-axis, right? This is our horizontal asymptote at y is equal to 0, okay? We see that happen too. So when you're graphing exponential functions, that's what we need to pay attention to. Asymptotes, the intercept, and that increasing, decreasing, and concavity as we go further. Now, the only other thing that we should keep in mind is the long-term behavior, right? So what can we say about that? We haven't addressed that. Okay, so long-term behavior in terms of arrow notation, right? We'd have, x is x to minus infinity, and then we'd have, f of x going to something, and then similarly, as x goes to positive infinity, f of x goes to something, and then as x goes to, I'm just going to jot this down, f of x goes to, and then as x goes to positive infinity, f of x goes to something else. Oops, okay. So let's look at this. In the blue function, what's long-term behavior? Okay, as I go to the left, okay, I am getting close to 0. As I'm going to the right, I'm going to infinity. So let's make sure that we reflect that down below. Okay, 0, infinity. And you can verify it as well, but as we go to negative infinity, when b is between 0 and 1, that's when we go to positive infinity, and then as we go to the right, we go to 0. Okay, so the long-term behavior switches depending on whether you have the value of b being greater than 1 or between 0 and 1, okay? And we have transformations, okay? So here we go. And then it says determine the domain range. Okay, goodness. Domain range asymptotes, and we'll only have a horizontal asymptote actually. Okay, So here's what I claim. I claim that the horizontal asymptote is -4. And the range is going to then be -4 to infinity. And the range and the domain is going to be all real numbers. Okay? Okay, so I was able to identify that right from the equation without even graphing it. Can you see where those numbers came from? Why do you think they're that way? More commentary on that in a minute. Okay? But if I think about this, what's going on? So this is going to go from 2 to the x, and then there's two things going on, a horizontal shift and a vertical shift. Okay, so I always do, CBAD, so I do the horizontal shift first, and then I would do the vertical shift second. Oops, -4. Okay, so this is horizontal shift right 3, and then this would be a vertical shift down 4. Okay, so what I'm going to do is I'm just going to sketch that base exponential function, and I already have it done. So I'm just going to I'll start in blue. That's what I did above. So 0, 1, there we go, and another one, and here we go, 1/2, 1/4. Okay, so there is my base graph of 2 to the x. Okay, now I'm just going to do what my transformations say. So I'm going to shift it to the right 3 units. Okay, so this is 1, 2, 3. There we go. 1, 2, 3. 1, 2, 3. Okay, and then there we go. Something like that. Okay, so this would be 2 to the x minus 3. Okay, the last one is just shifting it down 4 units. Okay, so I'm just going to take all the y values and shift them down 4. 1, 2, let's see, 1, 2, 3, 4. 1, 2, 3, 4, 2, 4, 2, 4, and then here are the other ones. And this would be 2 to the x minus 3 minus 4. Okay, so I was able to quickly graph this one because I already had the base graph down above, but if you needed to get the base graph using a table of values, please do. And from there, just be sure to use your transformations that you already know and love. Okay, now in terms of the domain, how did I know domain, range, and horizontal asymptote? How did I figure that out before even graphing this? Okay, domain. It already was minus infinity to infinity, and then all I'm doing is shifting it right 3. So just add 3 to the domain in each direction. Okay, fine, still infinity to infinity. Range, it was 0 to infinity before, right? That's the base one. Okay, range is the y value. So anything that's vertically impacting it is going to shift it. Okay, and shifting vertically by 4 is what we decided we needed to do here. So all I did was add -4 to each of the 0 and the infinity, and boom, there I have the range. In the same vein, the horizontal asymptote was at 0, but again, that's y, and I'm shifting y down 4, so that's how I went to -4 from 0. Okay, so this is fine to do beforehand. You can also do it after you make the graph and go from there. Either way is perfectly acceptable.